This lesson is for Advanced Algebra, Lesson 1-3 on function notation. In the previous lesson we were introduced to what a function is. Today we're going to start looking at how to write a function using the proper symbols. Most of the time students are used to seeing equations and working with them when they have an independent and a dependent variable listed. Independent variable is x, dependent variable is y. We learned that in the previous day's lesson. From now on, when you're working with a function or turning that equation into a function, you drop the dependent variable side of it and you give the function a name. Today, or for most reasons or most situations, we use f for function. Then the independent variable is highlighted in these parentheses, and then the rest of the equation stays the same. This particular type of setup of symbols is referred to as Euler notation. Now Euler is spelled a little bit different. Euler is the name of a person, and he's the person who decided to use this type of notation to indicate functions. So they called the notation after him. So it's Euler notation, and when you're using that kind of notation, you give the function a letter name, you put the independent variable in parentheses, and then you write the rest of the function or the rest of the equation after the equal sign. So just remember that the thing inside the parentheses is your independent variable. And the the letter in front is simply the name given to the function. So keep in mind that that letter could be just about anything you want it to be, but typically we avoid using x and y for the name of the function. Typically x is going to be the independent variable letter that we will use, so most often you'll see F or G or H or any of the letters in the alphabet that follow F as being the names chosen. The way that you pronounce this portion of the function when you say it out loud or read it out loud is you say f of x. So when you see those parentheses, you don't say parenthesis x, you say f of x. The other type of function notation that is allowed for students to use and need to be able to recognize is mapping notation. Mapping notation is very similar to Euler notation in that it gives the function some kind of a name. This time though, instead of using parentheses to highlight the independent variable, there's simply a colon used. And I'll explain how to say that in just a moment. And then again, the next letter listed is the independent variable. So when you say mapping notation aloud, you're going to say f maps. Then you do mention the variable, and then instead of an equal sign, they use an arrow. So you say f maps x onto, and then you say the rest of your formula. So students are going to practice using both types of notation today, and also practice their order of operations. So some of the benefits of using function notation is that the independent variable is easy to find. It's been highlighted either by the colon or the parentheses, so it's extremely easy to identify. Evaluating or calculating within a function is easy to do and easy to see. Make sure, students, that you don't forget to continue to follow the order of operations as learned in a previous lesson. We have several examples we're going to do, starting with example A. Evaluate f of x, which is equal to x squared, for f of 4. So you can see the way this question is asked. F of 4 means that you're going to replace x with the number 4, and then you're going to calculate. So I'm going to replace x with a 4 here, and also on the other side of my problem. The square needs to continue to be there. I don't need the parentheses because there are no parentheses indicated. So now I just go ahead and calculate. This side tells me what I'm going to do. The other side tells me what I'm going to do. Or how I'm going to do it, I should say. So on this side, we would actually go ahead and calculate using the order of operations. 4 squared is 16, and so that's the answer. So you'd finish off by saying f of 4 is 16. The next example uses mapping notation. If W maps R onto 4R minus 1, then W maps 6 onto what? So again, instead of the R, the independent variable, it's been replaced with a 6. So I'm going to do that in the problem. So they want us to map 6 into the R location. So I'm going to rewrite the problem with a 6 in place of R. I also included a dot here for multiplication because when numbers and letters are next to each other, multiplication is indicated. Now for this portion of the problem, I need to simplify using the order of operations. 4 times 6 is 24, and that takes priority over the subtraction. So 24 minus 1 is the next thing I would show, and when I calculate there, I get 23. So you'd finally say there, W maps 6 onto 23. One of the other things that students may have to perform when it comes to functions is writing functions in the alternate format. Here we're given an equation and they want us to write it in 2 other ways. They probably also mean here for us to write it in 2 other ways as functions. So we need to drop the dependent variable and focus on the independent variable. So the y is going to go away. The pi symbol here is not a variable, it's simply standing in the place of a number. The r is our independent variable. So if I write it using Euler notation, the r needs to go in parentheses, and then I need to give this formula some kind of a name. This looks to me like it's the formula for or it could be the formula for the area of a circle, so I'm going to call it A. My other form is probably going to be to write it in mapping notation. So I'm going to pick a different letter, and instead of using parentheses, I'm going to use the colon and then the arrow. And the rest of the problem stays the same. There is a challenge problem that I'd like students to look at. Some of the questions in the book are a little bit more intensive in that they involve radicals and further work with the order of operations. So here they give you the function f of x, and the function is equal to the square root of 36 minus x squared. One quick thing to help students remember, the grouping symbol here of the radical symbol means that these need to be performed before the radical symbol is taken. Now they want you to evaluate f of a and f of b and then subtract the results. So we're going to substitute in a for x and then b for x and then subtract the results. So if I take the function as the square root of 36 minus, plugging in a instead of x, I get a squared. Then I'm going to put in my minus sign and then do it again, this time with a b in place of x. 36 minus b squared. Now there's not a whole lot that we can do with this question because we don't know the value of a and b. So we can't really evaluate here. We can simply only go this far, and that's our answer.